Matthews Gatos here. Welcome to this video on combinations. Before we get started though, let's review permutations. So a permutation is any kind of an arrangement where order is important. So if I have three objects, A, B, and C, there are 6 permutations of those 3 objects. All of them are unique. Permutations in general are numbers, words, codes, passwords, lineups, playlists, arrangements, or groupings of people with assignable roles, tasks, or positions. Really, it's anything where order is important. A combination, however, is an arrangement of objects in which the order is not important. So whereas we had 6 permutations of A, B, and C, we only have 1 combination, because in combinations, ABC is the same as ACB. The order of the letters doesn't matter. So combinations are selections or card hands, choices, and committees with no assignable roles, tasks, or positions, because order doesn't matter. So if order doesn't matter for combinations, why are they called a combination lock? Shouldn't they be called a permutation lock instead? Something to think about. Permutations use the fundamental counting principle, factorial notation, or NPR formula or button on your calculator. Combinations, however, are the number of permutations divided by the ways of arranging the objects, since order doesn't matter. So there's 3 different formulas I want to show you for combinations. So the first combination formula I want to talk about is the middle one here, NPR, permutations divided by R factorial. R is the number of ways of arranging those objects. So since it's permutation divided by ways of arranging objects, notice here, this is the permutation formula. N factorial divided by N minus R factorial. So to turn it into a combination formula, I just also have to divide by R factorial, which is the ways of arranging the objects. Another way on the formula sheet that you might see combinations is these rounded brackets with a number on top and bottom. So for example, if I ever saw rounded brackets and a 4 and a 2 as an example, that really means the combination of 4 objects taken 2 at a time. So it's really just a different notation for combinations. Now, combinations can be found on your calculator in the probability menu. So you just do math, probability, and go to option number 3, which is your combination. Let's try an example. So in this first one here, I have 8 dogs in the cutest dog ever competition. I want to know how many ways first place, second place, and third place can be awarded. Now, is this a permutation or a combination? If you think about this, first place, second place, third place, it sounds like order is really important, which makes it a permutation. So let's look at all the different ways that we could award first, second, and third place. So for first place, we have a choice of 8 dogs. For second place, we have a choice of 7. And for third place, we have a choice of 6. So altogether, that is 336 ways you can award first place, second place, and third place. So while that is mathematically correct, I actually don't think there's 8 ways to award first place, because I think first place would go to my dog, Lady Lulu. Isn't she so cute? I think she would win first place, but that's just my opinion. Let's look at another example. Mateo wants to take 3 dogs with him on his morning walk. Now, if Mateo owns 8 dogs, how many different groups of dogs can he choose for his walk? So notice I still have 8 dogs. There's still 3 dogs that are being selected. But this time, I'm not saying first place, second place, third place. So this actually makes it a combination, because the order you select the dogs to go on the walk doesn't matter. So how would we figure this answer out? Well, if the order doesn't matter, let's start with where the order did matter. We saw that for first place, second place, third place, there were 336 ways that can happen. But since it doesn't matter the order he selects the dogs to go on the walk, I am going to take that number and divide by the ways of arranging the dogs. So I'm choosing 3 dogs, and I can arrange those 3 dogs in 3 times 2 times 1 way, which is 336 divided by 6. So the combination becomes 56. So you see, when I looked at the permutation of 8 dogs taken 3 at a time, that was 336 ways because order mattered. But if I look at the combination of 8 dogs taken 3 at a time, it's 56, considerably less because I don't have to worry about the order that I'm selecting the dogs. Let's try another one. So in this one here, I have 10 points on the circumference of a circle, and I want to know how many triangles I can form. Well, triangles need 3 points. So is this a combination question? If I have 3 points that I need, does it matter the order I select the points? It does not. It doesn't matter if I select point 7, 10, or 3, or point 3, 7, or 10. So this is a combination question because the order you select the points doesn't matter. So let's figure out how many triangles I can make. I have 10 points, so I'm looking at the combination of 10 points taken 3 at a time. So I can go onto my calculator to do this. So let's go ahead and do that. So I have 10 points, enter that in, and then I do math over to probability, and then option number 3 is my combination, and I do 10 points taken 3 at a time, and I can see that answer is 120. So back over here, I know that my answer is 120. Okay, let's try another one. Okay, how many ways can 6 players be chosen from a team of 15 athletes if Amber must be included as one of the players? Now, first of all, is this a combination question? I have 15 players. I'm just selecting 6. It doesn't assign roles or tasks, so it is a combination question. Now, if Amber must be included as one of the players, my tip is, since she has to be included, let's take her out of both categories because we're guaranteeing that she's on the team. So instead of having 15 athletes and selecting 6, I really have 14 athletes and I'm selecting 5. So I'm going to look at the combination of 14 athletes and taking 5 at a time because I'm guaranteeing that Amber is on the team. So again, you can punch that into your calculator and you would get the answer of 2002. Let's look at card questions. Card questions are really popular choice for combination because it doesn't matter the order that you have your hand. When you're dealt a hand of cards, you can rearrange them and you still have the same card hand. So just in case you're not familiar with cards, let's just review a little bit of the basics. There are 52 cards in a deck. This will be specified in a question. There are 2 colors. There are 26 black cards and there are 26 red cards. Now, splitting that down further, in the 52 cards, there are 4 suits, and those suits are clubs, spades, hearts, and diamonds. And then also special to cards are face cards, literally anything that has a face on it. There are 12 face cards. That's the Jack, Queen, and King. But again, all this information will be given to you in a question. Let's try an example. I want to know how many 5 card hands contain at least 3 red cards. So again, card questions are always going to be combinations because the order, if you change them around, you still have the same cards. If I want to have at least 3 red cards, at least means a minimum of 3. So you have a minimum of 3 red cards. Notice you can have 3 red cards, 4 red cards, or 5 red cards. But I always have to have 5 cards in my hand. So with the 3 red cards go 2 black cards. With the 4 red cards go 1 black card. And with the 5 red, 0 black cards. So let's fill this in terms of a combination. Let's do our red cards first. So 26 cards in the deck, and I want 3 of them. 26 cards in the deck, I want 4. 26 cards in the deck, I want 5. Let's look at our black cards. 26 black cards, I want 2. 26 black cards, I want 1. 26 black cards, and I don't need any. Now, that is a lot to enter into the calculator. That's 1, 2, 3, 4, 5, 6 different things that you have to enter in. But I have a little shortcut for you on the calculator. So looking at the calculator, a little tip that I have for you here is instead of entering them all in individually, we can use rounded set brackets found above the regular brackets and combine the combinations into one notation. So if I go back over here, what I want for the red cards is I want to look at 26 red cards, and I'm taking them 3, 4, and 5 at a time. For the black cards, I have 26 black cards, and I want 2 of them, 1 of them, and 0. So let me show you how you can put this into your calculator to make your life a little bit easier. So into our calculator, let's do the red cards first. So 26, go into math, over to probability and combination. And then I'm going to use my squiggly brackets, which is above my regular brackets. And I'm looking at 3 cards, comma, 4 cards, comma, 5 cards, and end my squiggle brackets. Those are the red ones. So this first number is 26C3, 26C4, 26C5. Let's do the same thing for the black cards. So 26, go into your combination, which is option number 3, squiggly brackets, and I'll do 2, comma, 1, comma, 0, and close my brackets. Okay, so this first one is 26C2, 26C1, 26C0. So that's going to help me when I am doing my calculation. So now I can just do, okay, let's look at the red cards first. So I see that 26C3 is 2600. I see 26C4 is 14,950. 26C5, bigger number, 65,780. Now let's go into our black cards. 26C2 is 325. And I'll add that 2 because it's or, it's cases. The one black card, 26, plus no black cards would just be 1. So I can take these products and add them together much easier than entering it individually into my calculator. When you do that, you're going to get a big number, 1,299,480 cards that have at least 3 red cards. 5 card hands, at least 3 red. Okay, let's try another one before we get to that. A couple common combinations that might be worth remembering. NC0, just like we did with the black cards there, 26 black cards. And if I don't choose any of them, there's only one way of doing that. NC1 is just N. And NCR is the same as NCN minus R. Here's what that means. If I have N objects and I'm selecting R, it's the same as having N objects and not selecting N minus R. Here's an example. 5 selecting 2 is the same as 5 not selecting 3. That one comes up from time to time, so it's definitely worth remembering. Okay, and our last question here. We have a business meeting and there are 120 handshakes. Oh, back in the day when we could do handshakes. If every person shakes hands with everyone else, how many people are at this meeting? Well, handshakes are another form of a combination because the order that we shake hands doesn't matter. So I know this is a combination. I don't know how many people are at the meeting, but I know it takes 2 people to do a handshake and there are 120 handshakes. Let's apply our formula. So n factorial over n minus 2 factorial times 2 factorial equals 120. So we're going to simplify this. First thing that I'm going to do is get rid of my 2 factorial on the bottom just by multiplying both sides by 2 factorial. So 2 factorial divided by 2 factorial is gone. On the other side, 120 times 2 factorial is just 240. Okay, on the other side here, I have a factorial. Remember, I want to expand my bigger until it matches my smaller. So what I'm going to do is expand. Let me just make that a little bit bigger so we can see it. There we go. I'm going to expand the n factorial, and I'm going to go one less, and I have a match, so I can stop, because the only thing that cancels a factorial is an identical factorial. So then I have n times n minus 1 equals to 240. So I have a quadratic. Let's just apply the distributive property. So n times n times negative 1, and I will subtract 240 from both sides to set it equal to 0. Again, I do that because it is a quadratic and you want to factor and set each factor to 0. So I'm going to look for two numbers that multiply to negative 240, add to negative 1. So I know that those numbers are negative 16 and positive 15. So I set each factorial equal to 0. And here I add 16 to both sides. Here I subtract 15 from both sides. Well, I'm looking for the number of people that were at the meeting, and I know I can't have a negative number of people, so that doesn't make sense, and I'll write extraneous, which means it's a solution to the quadratic, but not the original equation. So I think the answer is 16, that there are 16 people at this meeting. But anytime I do a solving question, I always want to check. So I go into my calculator and I enter in NC2 into Y1. I go into my table, because remember, the check always happens in the table, and I see when there are 16 people at the meeting, there are in fact 120 handshakes. So I know I did that correctly. Okay, so a lot of number combination calculations that we've done in this video, so I thought it only appropriate to ask you a question about numbers. What do you call a number that can't stand still? Well, there you go. What is that number? Well, it is a roaming numeral. If you liked this video, please give it a thumbs up so I can help more mathies just like you. And subscribe to my channel as well so you can be alerted to new videos. Thanks for watching, and I'll see you for the next one.